Hey guys, so I'm going to walk through the solution to question number 1 on the All You Need Is LUG worksheet. Here's the question. Find the period of the moon's revolution around the Earth. I can probably be worded better. But find the period of revolution of the moon around the Earth. So this is a kind of tough question here. So let's start with what we know. Well, we are looking to find the period of the moon's revolution. So that's our unknown. And you could think to yourself, okay, well, where is period used? How is period defined? Well, period pops up in the equation that v equals 2 pi r divided by t, where that speed of an object traveling in a circle is equal to the circumference divided by the period amount of time it takes for one revolution. And it pops up there. The problem with that is we don't know v. We do know r. The problem gives us r. We don't know v. So this is maybe helpful, well, hopefully helpful, because it's the only time period pops up on your front side of your equation sheet, I think. So we can use it, and we will use it. But we're going to have to look more at the physics involved before we get there. So first of all, with questions like this, basically all questions like this, you should ask yourself, okay, well, I have an object traveling in a circle. In this case, it's the moon. How is the moon kept in a circular path? And the answer here is that the moon is kept in a circular path by the gravitational force. The gravitational force of the Earth, or between the Earth and the moon, more accurately, keeps the moon from traveling out in a path tangent to its orbit and like way out into the solar system and who knows where. So the gravitational force provides the centripetal force. It's always vitally important that you figure out what provides the centripetal force. In this case, it's gravity. So that's a good place to start. That will pretty much always be a good place to start. What provides the centripetal force? And if you have an expression for it, set them equal, and go from there. So in this case, that's just what we'll do. This will be helpful. And if you know the definition of centripetal acceleration, that it's equal to v squared divided by the radius, hopefully it's a little even more so, because you recognize, okay, well, our period is going to pop up there, and our v is going to pop up in here, and this is going to pop up in the equation that mass times centripetal acceleration equals centripetal force. So this problem needs to start by stating that the centripetal force keeping the moon in its gravitation in its orbit around the Earth is provided by the gravitational force of attraction between the Earth and the moon. And you got to start there. From there, you have 2 routes you could possibly take. 1, you could solve it algebraically. 2, you could solve it numerically with a whole bunch of numbers. So I'm going to stop this video here, and then I'm going to do both solutions in like separate little video blurbs. So it's going to start here. Probably the most important step. From there, it's going to get a little fancy looking, and it's going to look all hard and mathy, but it's really just algebra. This is like the most important step as far as physics goes. So if you have questions about it, let me know.